Okay, so let's practice solving some integrals. So in the first problem, you should notice that this you can simplify a little bit. So m cubed minus 1 squared, or not simplify, but like expand. So m cubed minus 1 squared is going to be m to the 6th minus 2m cubed plus 1 over m to the 5th dm. I forgot a dm here. All right, and when you solve that, that's just the same as the integral. And notice that I'm keeping this in an integral as I rewrite it. dm. All right, and then the antiderivative of m to the first would be 1/2 m squared. The derivative of negative 2m to the negative 2 would be negative 2m to the negative 1. And the reason for that is because if I multiply negative 1 in front, I get negative 2. And then if I subtract 1 from negative 1, I get negative 2. Remember, m squared in the denominator is m to the negative 2 in the numerator. And then 1 over m to the 5. So m to the negative 5 would be negative 1/4 m to the negative 4. Okay? Multiply the 4 in front, subtract 1, you get negative 5. And this is an indefinite integral, so don't forget your plus c. Now for this next one, we're going to be taking the derivative, and there is a really simple way to do this if you understand the idea behind taking the derivative inside of an integral. But if not, just go ahead and take the derivative, okay? The derivative of x squared plus 11 is going to be 2x times 1/2 x squared plus 11 to the negative 1/2. Now notice that this is still inside the integral because I haven't solved the integral. All I've done is taken the derivative. Okay, so now let's find the antiderivative. Well, what's the antiderivative of something I just took the derivative of? What is the antiderivative of something I just took the derivative of? And it's going to be what I originally had, right? The antiderivative of something you just took the derivative of is going to be what you started with. So I can take what I started with out of the integral, and I'm going from 0 to 5. Okay, so again, I had to take the derivative first, so I got some function. In fact, let me do it this way. Let's take it out entirely, okay? Let's say I'm taking the integral of 0 to 5, derivative of lowercase f of x dx. Okay, well, what is the derivative of f of x? F prime. Okay, what's the antiderivative of f prime? F of x, right? You just end up with the original function. So that's why I ended up with the original function here. I took the derivative, then I took the antiderivative. So it goes away. And then I just get the square root of 25 plus 11 is 36 minus the square root of 0. So that is 6. Okay. All right, likewise, now I am taking the derivative of an integral of a derivative. Okay, well, I already did this. The derivative of a function is f prime. Then I take the antiderivative of f prime. Okay, so now I am finding the derivative. The only part I haven't done is taking the derivative of my answer, which was 6. Right? I already solved this part. Now I am taking the derivative. So you always work like inside out. Like, so first thing I did was I took the derivative, then I solved my integral. Now I'm taking the derivative. Work inside out. The derivative of 6 is 0. So you should notice that anytime you take the derivative of a constant, because this is a definite integral will give me a constant, and the derivative of any constant is equal to 0.